What's up, everyone? Welcome back to Better Biomed. Folks, today we're going to be troubleshooting a refrigerator. And this is a very simple one, so it shouldn't be very difficult. I've already done a little bit of the troubleshooting because it's interesting. I had to learn a lot about refrigerators in order to make this happen. So they're not like other AC motors. They're built a little bit differently. See, a traditional AC motor is going to use a start-run capacitor, and refrigerators don't do that. They have two different components that work in tandem. We have a safety device, which is basically a thermal circuit protector. And then we also have, this is a bad example, but we have a little starter relay. Now, the unique thing about these compressors is that there's two different coils inside them. So you have a start winding and then you have a run winding. And you have a third terminal, which is going to be common. So your schematic is going to have three little pins. Your top pin is going to be common. The furthest pin is going to be your start winding. This one here is going to be your run winding. And the way the schematic looks is we have a red wire which is going to connect to the thermal overload protection device, and they all just slide on, interestingly enough. And yes, this is definitely unplugged, folks. All right, so now you can see the three little pins as I described. They are right there on the side. So the top one is common. You're going to have your start and then your run winding. And your run winding is going to have neutral connected. Your start winding is going to have your hot, and your thermal overload protection is going to be connected to your common. So that will disconnect either coil if it is over temp. All right, so the way that this works is when you plug it in and when it starts the compressor, it's going to momentarily fire up the start winding, and there's going to be this positive temperature coefficient device inside that relay, and as this guy gets warmer, it's going to increase in its resistance, and that will eventually disconnect your start winding so that you're only running off your run winding. Interesting. You can see this guy right here had a bad day, and that's what generally is going to happen, is that relay will go bad. All right, since it is not cooling and my compressor gets rather warm, so we're going to go ahead and do some troubleshooting on the compressor first, and then we can figure out if your relay is going bad. Now, I already replaced the relay because it's had a rough life. You can see the PTZ, power temperature coefficient element, is already had rough life, so we changed it out. It's still not starting, so let's go ahead and test the compressor to see if we have continuity with ground, which would indicate a shorted compressor. No. Okay, so now we're going to go from common to the other legs. 5.9 ohms. This here's the start winding, 7.8 ohms. I would normally say that that is a good compressor. 14.2 ohms. They're a little bit high on the resistance, but I normally would say that this compressor is good. So I changed out the thermal overload protection, and I also changed out the relay. And let's go ahead and take a look inside the relay, show you what it looks like. Now, I kind of boogered this one up, so it could be my fault why it's failing. So let's go ahead and open it up. I'll show you what it looks like on the inside. All right, and here you can see my positive temperature coefficient element, and it's sitting there in between two brushes. Nice and even, no burning, no score marks, and it will actually join those two until it gets warm, and then it separates them. So that connects and disconnects the start winding. So at this moment, I plugged it in. You can see some signs right here of temperature overloads. So that's not a good sign. It means that this guy has had a rough life. And what happened is I went away on a trip, work trip, and then when I got back, this guy here was very hot, and it kept bouncing off thermal overload protection, this guy right here, which means that this guy sat at a very high temperature for a long time, and I do believe it's seized up. It will sit there and it will just buzz, kind of like it wants to start, but it will not spin up, and that is not good. So I do believe the compressor was damaged. Now both the coils are showing that they're good. However, if the piston itself is froze up, then it won't be able to move. And even beating on it a little bit to try and change the resistance doesn't seem to change anything. So at this point, it's probably going to be a loss, the entire refrigerator, but it's because it's just simply not worth it to change out this little compressor. But if you did have an HVAC reclamation kit, you could capture the Freon that's inside this guy, because I do believe that is perfectly fine. And you could change out this compressor very easily. All the points are very accessible. So unfortunately, I don't believe that this one's going to be repairable. I might goof with it a little bit more, but it's definitely appearing like it's froze up. So unless I could really shock the heck out of it while it's trying to start, it's just going to be dead, unfortunately. So there you have it, guys. Troubleshooting a refrigerator compressor. Just remember, there's 3 terminals. There's 2 separate coils, and you'll have a start and a run coil and a common terminal. And none of those terminals should have continuity with the base. That would indicate a short, and you're automatically going to be bad. These guys here are very inexpensive. You can buy replacement, and they sell them as a kit together because they're changed out as a set, and they're about $10. You can find them on Amazon all day long. Just remember that when you connect it, remember not to connect it on the same side, because you will absolutely fry your element, which I definitely did not do. Alright guys, hope you learned something. Refrigerators are very simple electronics, easy to troubleshoot, and when in doubt, there are schematics on the back of the refrigerator. Actually kind of cool. So there you have it, guys. We can't fix them all, unfortunately, but certainly gave it a go. Thanks for watching. I'm here to help you guys with any of your test equipment needs, whether you need a quote or you just have a question about functionality. It's no problem. Just go ahead and shoot me an email at jbarber@bcgroupinternational.com or justin@betterbiomed.com. It's my pleasure to help you.